Throughout this unit, I've been trying to emphasize that a relation, which remember is just a connection between two quantities, they can be represented in a number of ways: a table, a graph, an equation, and words. I have a relation here in words. It says that we have two numbers that differ by 3, and we want to represent this relation in the other ways. So I'm going to begin just so we can talk about these two numbers more clearly. Let's define our variables. Let's let x equal the larger of the two numbers and y the smaller. And if the two numbers differ by 3, we could say that the larger minus the smaller is equal to 3. So there's our relation in algebraic form. And now what I'm going to do is build a table of values and a graph just so I can see the relation in other ways. So let's just take a number. If two numbers differ by 3, that's basically what I'm looking for, where x is the larger number. If I had 3 and 0, 3 minus 0 would be 3. It would satisfy this equation. Or 4 minus 1, that would satisfy this equation. You'll notice that I'm getting points for the equation without having y isolated. And that's kind of the focus of what I want to talk about in this video. You don't necessarily have to have y isolated in your equation to find points for the relation. You can think about it in terms of what it means, and then there's some other ways that we'll talk about. So I could have 5 as one number, 2 as another, because they differ by 3. I could go back to 2. This would then have to be negative 1, because 2 minus negative 1. The difference of those two numbers is 3, and so on. I also know that this is a linear relation, remember, because my equation is a first degree. There's no more than an exponent 1 on the x and y. And since it's linear, I know that the pattern in the table will mean that the x's go up by a constant amount and the y's go up by a constant amount. And so since I have a number of points already, I can back this up a little bit, back the table up. The number before this would have been 1, and this would have been negative 2. And there's a good sampling of points for this relation. So let's graph them. 1, negative 2, 2, negative 1, 3, 0, 4, 1, 5, 2. And because of the pattern, I can see that 6, 3, 7, 4, 8, 5, 0, negative 3, they would all lie on the graph. They would be part of this relation. And so would all of the points in between, all of the decimal values. So I can connect with a solid line. My relation is represented in 4 different ways. Alright, here's another relation. This relation is given in equation form. If I wanted to think about it in terms of words, it might be that twice one number plus 3 times another number has to always be equal to 6. That's our pattern relationship connection. And so we want to represent this relation in terms of a table and a graph. You'll notice in this question, unlike many of the others we've done, it's not starting with y equals something involving x. We've done questions like this before where we pick any value of x and work out what y is. This time the x and the y are together on one side of the equation. And so I'm just going to work with this equation as it is in terms of finding my sample points. So all I'm going to do is I'm going to pick some random values of x. Let's suppose, let's just take x equals 0. That's a nice number to start with. And let's just substitute it in just right where it is. So I'm going to go 2 times 0 plus 3 times y is 6. 2 times 0 is 0, plus 3y would be 3y. And so if 3y equals 6, dividing by 3 means that y is equal to 2. So the condition is that when x is 0, y has to be 2. Alright, there's 1 point on my relation, which by the way I know is linear because it's a first degree equation. So I know that I should get a line, I should get a constant rate of change on both the x and the y in my table of values. Alright, let's choose another value for x. Actually, let's choose a value for y. Let's say y is equal to 0. So we don't normally pick for y, but let's just do it in this case and see. we get 2x plus 3 times 0 equals 6. 3 times 0 is 0, so we get 2x is equal to 6. Divide both sides by 2, and so I'm saying that x has to be 3 when y is 0. So I can put that in my chart. Alright, and I'm just going to plot these 2 points, 0, 2, 3, 0. Now remember, we indicated earlier that our linear relation above is a line because it's first degree. So actually, I only really need 2 points to graph a line, and I could just connect the points and be done here, but let's just do a couple more just to confirm that our pattern is linear. Let's take another value for x. Let's take x equals -3. So I'm putting -3 in for x. 2 times -3 plus 3 times y is 6. 2 times -3 is -6. Alright, and so I have an equation I need to solve. I need to get the y by itself. So I need to get rid of the -6, so we add 6 to both sides. 3y is equal to 12. Divide both sides by 3, and so y must be 4 when x is -3. So we'll put that in the table. And plot that point as well. You'll see that it's lining up with the other two. Another way to check our work is, let's just make sure we're getting a linear pattern in our table. As we go up by a constant amount of x, I'm jumping by 3 there, going down the table, my y is going down by 2. So the rate of change, the change in y over the change in x, is that y is dropping by 2 for every increase of 3 for x. And so if I just wanted to write another point in here based on the pattern I see, this would have to be -6 and this would have to be 6. And let's put that on the graph. Just to confirm, this point should work in that equation. Let's just check that it does. If x is -6, 2 times -6 plus 3 times +6, question mark, does that equal 6? Multiplying -12 plus 18, yes, that does equal 6. So that point is on the graph. And to show that all points along this pattern work in this equation, we join the pattern with a solid line, arrows on the end to show the pattern goes on in both directions. So you don't have to isolate y in your equation to get points for the table of values. Select a number for one variable and find the other using algebra. Alright, here's another pattern. X is equal to 2. It's a very simple equation, isn't it? X is equal to 2. What's the pattern? X is equal to 2. It's saying that x has to be 2. It's not saying anything about y, so y can be whatever you want. I'm just making up a bunch of points here. Off I go to graph. 2, 1, 2, 0, 2, -4. All the points, when x is 2, lie along this straight line. I get a vertical line, and that's my relation. And now we got y equals 2. And you probably guessed it. Y has to be 2. That's the condition. What does x have to be? It doesn't say. So if it doesn't say, it doesn't matter. You can pick anything you want for x. And when you plot them, -1, 2, 0, 2, 2, 2, we're getting points all along where y is equal to 2 on the graph. And so I get a horizontal line.